Guys, in this video we will be talking about finding a volume and surface area of a rectangular prism. A rectangular prism is a three-dimensional figure. Okay, what does that mean, three-dimensional? So if you look at a line segment, we can say the line segment has a length. So this is just one measurement. If we are looking at shapes such as rectangle, this is a two-dimensional shape because now it has length and it has height. So it has two dimensions, right, versus one. And then if you look at the rectangular prism, for example, or box, looking that's the ugly looking rectangular prism, but it's okay, we'll go with it. So this rectangular prism has length, it has height, and it also has a depth, right? We call it a width. So length, height, and the width. So it has three dimensions. So that's why they are. The difference between the two-dimensional and the three-dimensional shapes is the three-dimensional shapes have volume. Okay, we can put stuff inside them. They can hold something inside, where two-dimensional shapes don't have that capacity. So volume is the amount of space occupied by a three-dimensional object. Exactly what we just talked about. So which formula would be used to find the volume of a rectangular prism with a height of 3 meters, length of 4 meters, and a width of 2 meters. So we're going to look at this example together. So first of all, you will be provided a formula sheet on your test, so you don't have to memorize those formulas, which is a great thing. So what you would need to do is to find the shape you're working with on your formula sheet, and then find the formula that relates to your question. So we're being tasked to find the volume of this rectangular prism. So volume, V stands for volume. So this is here's my formula. I always like to start with writing out my formula. Okay, and identifying the components in this formula. So length, width, and the height. We are told in this problem that the height is 3. So I'm going to put that next to height, 3 meters. We are told that the length is 4 meters and the width is 2 meters. So this box, so this prism is 4 by 2 by 3. So if I'm looking at this formula, LW height, if I don't have any operations in between my variables, that means I have to multiply them. So I can put them in parentheses if this helps. So what I need to do next is just simply replace my variable with the values that are given to us. So L is 4, W is 2, times height is 3. So the only thing I have to do now is multiply this number straight across. So 4 times 2, I'm going to do 2 at a time. 4 times 2 is 8, times 3 is 24. So my answer is 24, and I always have to put a unit of measurement for this types of problems. So it is meters. So 4 meters times 2 meters times 3 meters would be 24 cubic meters. So we have to put m for meters with 3 as an exponent, a power of 3. So this is when it comes to finding the volume. So really simple, we just need to multiply 3 dimensions together. Now, surface area. Surface area is also simple, relatively simple. The formula is slightly more involved, but the problem is not a big deal. So surface area, okay, surface area is the total area of all faces of three-dimensional figures. So what does that mean, those faces? So if you look at the box, so if we take this image, let me draw a bigger one. You don't have to draw this with me, but I will erase it later. So if I'm looking at the box, right? All right, what do I have? Okay, that's better. So it will have a front size, right? I'll have a front. Okay. And this front size will be identical to, I'm going to make both of them blue, to the same, to the back side of my box, right? Then it will have a side, okay? And this side, yellow side, will be identical in size to the opposite side of the box. And then we also have top and the bottom, okay? So top and the bottom will also be the same size. So this is a little messy, but the point is, so we have two blue, two yellow, and two green sides. So that is total of 6 sides. So in a three-dimensional shape, we call the sides faces. Okay, that's why they're telling you of all faces. So if I know area of each side, it makes sense if I add them all together, I will find the area of the entire three-dimensional figure, right? So the formula that you're going to use for this is as follows. So surface area is equal to 2 times length times height. So this is me finding the area of the front and the back, if you will. Let me just redraw the shape again. Okay, because it's two of them and they're the same. Plus, we need to find the area of 2 times length times, oh, did I not do it right? All right, it's not a big deal, but let's just follow the formula. So length times width plus 2 times length times height. So when I multiply length and the height, I will find the area of, let's just say, this side shape. And because we said these two sides are the same, that's why we're doubling the area. And then we need to find the area of the top of our box and double it as well, because we said the top will be the same size as the bottom of the box, and that's why we're doubling that. All right, so you start off with the formula and do same exact thing. You just simply substitute your values into the formula. So we know that the height of our prism is 3 meters, the length is 4 meters, and the width, whoops, and the width is 2 meters. So here we go. And I'm going to write it out horizontally just like this written out to you, but then I'll show you another way you can organize this information and it might be helpful to some. So we have 2 times length times width. So length is 4, width is 2, plus 2 times length times height. Length is 4, height is 3, plus 2 times width times, let's rewrite that, times height. So width is 2, height is 3. So if you notice, I've used each number twice. So I've used 4 twice, I've used 2 twice, and then I've used 3 also twice. So that kind of keeps you see the pattern. So I'm going to multiply now this multiplication parts first. 2 times 4 is 8. 8 times 2 is 16. 2 times 4 is 8. 8 times 3 is 24. 2 times 2 is 4. 4 times 3 is 12. So the only thing is left to do now is to combine area of those faces that we just found. So 16 plus 24 plus 12 is 52. Okay, and surface area will always be square units. So meters squared to the second power. Okay. I'm going to erase this really quick. You don't have to write what I'm doing next. Just watch and see if it helps you understand this formula better. If you already understand it, great. Okay, so some people like to write out this formula vertically. Okay. Okay, so we have 2 times length times width. So I just rewrote this part. Plus 2 times length times height. So that's the second part of my formula. Plus 2 times width times height. That's the third part of my formula. Okay, again, replace your values. 2 times length was 4 and the width was 2 equal 2 times length was 4 and the height was 3. Okay. And the last one, 2 times width was 2 and the height is 3 meters. Okay. Now solve each of them separately. 2 times 4 is 8. 8 times 2 is 16. Same number. 2 times 4 is 8. 8 times 3 is 24. Yep, so the same number. 2 times 2 is 4. 4 times 3 is 12. Now add them together and you will get the same exact answer, 52 square meters. So just another way to organize this information, not a big difference. All right, so the next portion of our nets we will talk about is nets. What are nets? So a net is represents, whoops, net. And that represents a two-dimensional representation of a three-dimensional shape. So think about a box. If you take a box and then you unfold it, this is what the box could look like. Okay, and you just need to be able to look at the net. Here's the net. Make this. Okay, here's the net. Okay, you need to be able to look at the net and say, oh, if I fold this net together, this will fold into a box, a rectangular prism like that. Another thing you need to be able to do by looking at this net is to identify which number represents length, width, and height. So, but really, truly, it does not matter. As long as you pick one number to represent each dimension, you will be fine. So I have 4 numbers right in this picture. So one of the numbers is repeating itself, and I can tell it's 3. So what I can do is to say, well, the length of this prism standing on it is 3 and it's centimeters. Okay, then the height of this prism, how tall my prism is 6. Okay, so this is my 6 centimeters. Let's color code that. So this, and this sides would all be 3 centimeters. And then the height of the prism, 6, will be, okay, this part. So the height is 6. And the depth or width of the prism is shown up to us right here. So when you fold it, how deep that box is. And this box is 2 centimeters in depth. 2 centimeters. Okay. And then you can pull these numbers to find your volume. And then you can use these numbers now to find your surface area if you have to. Okay. The next part we're going to talk about are word problems. And the word problems, it might not always be very clear to what they want you to find. So if you're working with word problems and you come across words such as how much does it take to fill the pool or fill the can, or how much it can hold, or how much it take how much space it takes. All right, so space is a good one. Space it takes. But any word that indicate inside the shape, okay, is going to be referring to volume. The volume again is always going to be cubic units. So units to the third power. The words that could indicate that the word problem is asking you for surface area are if they ask you how much paper does it take to wrap the box, okay? Or how much paint will it take to paint my I don't know, project? How much material does it take to make aluminum can? something like that. Anything that indicates the outside portion of your shape is going to be surface area kind of question. And surface area is always going to be square units, unit to the second power. All right, so here's an example. Ricardo has a present that he would like to wrap. There we go, keyword right away. Talking about wrapping, let's keep the blue stuff together. How much wrapping paper would he need to cover his rectangular present if the box is 5 foot tall, 3 feet wide, and 4 feet long? Okay, so let's add another word to our bank. So another word right here could be cover. All right, cover. So you don't really need an image because they're giving you all the information you need right here. So we can draw that or we cannot draw that. But I do like to write out what we have. So we have length, height, and width. So the box is 5 feet tall. It is 3 feet wide and 4 feet long. So what is this? Is this the surface area or volume? So the way I like to think about this question is this. Now, am I going to take this paper, wrapping paper, and stuff it inside the box to fill in the space inside? Or will I take this wrapping paper and wrap it on the outside of the box? And I'm going to do it on the outside of the shape. So hope you do too. So this is your surface area kind of question. Okay, surface area is 2LW plus 2LH, 2 times W times height. Okay, and all these parts, the multiplication part, the multiplicative parts are interchangeable. So you can do 2 times length times height first, and whatever. So anyhow, don't get too hung up on which part of the formula needs to go first, second, and third, as long as you're using length twice, width twice, and height twice. All right, here we go. Let's fill them out. I have 2 times length times height. Width. Length is 4, width is 3. 2 times length times height. Length is 4 and the height is 5, plus 2 times width times height. Width is 3, height is 5. So multiply all these 3 parts together first. So multiply, multiply, multiply numbers in the box, and then add them together. Very simple. 2 times 4 is 8. 8 times 3, 24. 2 times 4 is 8. 8 times 5, 40. 2 times 3, 9. 9 times 5, 45. Done. Okay, so just adding them up together. 24 plus 40 plus 45 is 109. And where would I write that? Let me erase this part. So he needs a 109, okay, that was feet, right? Square feet of paper to wrap this box. Next question, water tank is 90 meters long, 60 meter wide, and 40 meter deep. How much water he need to fill the pool, right? So the same person, I'm assuming, is filling the pool now. All right, are we gonna take water and just kind of put it outside the pool? No, we're gonna put it inside. So inside, and the keyword right here, fill the pool. And the water is not going to be definitely just standing outside the shape. Water is something that's going to go inside the shape. So this question is definitely asking us to find the volume. All right. So my dimensions are length, width, and the height. It is 90 meters long, it is 60 meters wide, and it is 40 meters deep. And my formula is length times width times height. So the only thing I need to do with these 3 numbers is to multiply them together. Easy breezy. So 90 times 60 times 40 is, ooh, big number. 216,000 cubic meters of water. Okay, I want you to finish up the last question by yourself. You are given a truck, you're given dimensions of the truck, and you need to find the volume and the surface area of this truck. Please continue working. Let me know if you have any questions.